Problem number 5 asks you to construct a regular octagon using the rotation method. This is the method that we use like when we constructed the Ferris wheel and then through the regular polygon quest. But what we do is there's no size restriction on this one, so we can make it whatever size we want. So I'm going to grab the circle tool. What you would do on paper is put your center first, draw a center point, and then draw some circle, right, with some radius. Okay, and then when you put a point on the circle and then draw that segment, draw that radius of the circle, okay, that's going to be our rotated point and rotated segment. That's going to get us to the next vertex of this regular octagon that we're trying to make here. Okay, so how far do we rotate? Well, we take 360 degrees, which would be the full rotation for this point B, right, around point A. Take 360 divided by 8, since we're talking about an octagon, which I believe, let me get the handy dandy calculator. Let's check that out. 360 divided by 8. 45. Okay, so 45 degrees is our rotation. Put that here. Oop, got this bad mouse here. Okay, so let's rotate this 45 degrees. So I'm going to go to my transformation toolbox, grab the rotate object by point. Okay, I'm going to click on B, and then I'm going to click on A to rotate around A. Hey, look at that, 45 degrees. Let's go counterclockwise. There's one. I'm going to click on B prime. A, rotate that 45 degrees. There's another point. And I'm just going to continue to do this until I have all 8 points. Right? By hand it's not as easy as this, but you can use your protractor and just measure off 45 degrees, mark it on your paper, and just keep moving around till you have. Remember that circle too, we use that so that we can measure this equidistant of these radii here. Okay, these aren't really part of the regular polygon. The regular polygon actually, and in this polygon toolbox too, if you click the down arrow, there's a regular polygon tool. Okay, so what you do is you click on 2 points to be like the side of the polygon. Then we just say how many vertices it has, like 8. Oops, and I clicked the wrong direction. So I'm going to undo that and just click the opposite direction here. Do 8. And there's our regular octagon, right? That we got those vertices from that rotation method. Okay, problem number 6. There's 7. Number 6, find the length of AC. So we want the length of this segment right here. So we can think of this as like a translation. C translated to A by going, let's see, 1, 2, 3, 4, 5, 6, 7, 8 units to the right. And went up 1, 2, 3, it looks like. Okay, so this is just a Pythagorean theorem question because we have a right triangle. The relationship to find this length would be to square this side, which is 64, right? Like an area of a square. And we're going to add to it this side squared. 3 squared is 9. 64 plus 9, add those up. I think we get 73, right? So remember, that means that that's this side squared, right? Because we're talking area, it's equal area. So C squared equals 73. Therefore, C is just going to be the square root of both sides, right? So C is the square root of 73. So the exact length of AC is an irrational number, square root of 73, which is about, so I'll use the approximate signs. And let's use the calculator here and find out what that is. So square root of 73, 8.544. So just about 8 point, we'll say 54. So that's the length of AC using Pythagorean's theorem and using our translation concept of thinking about horizontal and vertical movement. Okay, and then number 7, write the vector notation for this vector below. What is the length of the vector? So just like on number 6 here, if you think about this point here translated to this point by going down, looks like 2. Okay, and then going to the right, 1, 2, 3, 4, 5. Then the vector, if we go horizontal notation, remember we use the pointy brackets. It's kind of like an ordered pair, but we use the pointy brackets so we don't confuse the vector with an ordered pair that uses the round parentheses. But we do horizontal movement first, then vertical. So vector notation would be like this. If we went vertical, horizontal, vertical. Either way. And then how long? Well, these are just the side lengths here, right, from the vector. So we just square this number, add it to this number squared, right? 5 squared is 25. Add it to negative 2 squared, so negative 2 squared, right? Those of you using calculators, make sure that you put the negative number in parentheses. Negative 2 times negative 2 is a positive 4. We always get a positive out when we square. So add them up, we get 29. So the side length of this is automatically the square root of 29. So that would be the length. If we wanted to check it out decimal wise, again we would grab our calculator. Square root 29, 5.39, we'll say. 5.39. Okay, there we go. There's our answers 5 through 7.